Hi everyone, welcome to Chapter 6, Part 2. Today we are going to continue our talk about ionic bonding. So last time we talked about simple ionic bonds that are formed between a metal and a nonmetal. And these are going to be metals and nonmetals from the main group elements that have just one charge. Well, some metals have variable charges, and these will be transition metals, so the ones that are found in the D block. And they can often form more than one type of cation. For example, copper can exist as copper 1+, or it can exist as copper 2+. So copper can lose either 1 electron or 2 electrons when it's forming ionic bonds. And so to specify which one of those that we're talking about, we're going to use a Roman numeral placed directly after the metal in the name. So like iron 3. That's telling you that iron is going to be a 3+ in this compound. So iron 3 chloride means that we're having iron 3+ and Cl1-. So when we use Fe3+ and Cl1-, if we circle and switch, that 3 is going to the chlorine, which is why we get Cl3, and the imaginary 1 is going to the iron, which is why it's just Fe. When the metal only forms one cation, like sodium, there's no need to use any Roman numerals because it's redundant, right? We wouldn't write sodium 1 because sodium is always a 1+. So we're only going to use it if there's an atom, right, a metal that forms more than one charge. And this will be our transition metals predominantly. Okay, the exceptions to the transition metals are going to be zinc, silver, and cadmium. So I want you to memorize these three. They are the only three transition metals that you need to memorize. So it's zinc, silver, and cadmium, and they only form one charge. So zinc will always be a 2+, silver will always be a 1+, and cadmium will always be a 2+. So those three I want you to know. Otherwise, if you come across a transition metal, assume that it makes more than one charge, and you're going to need to have a Roman numeral. So, like I said, for metals that form two or more different ions, we're going to write a Roman numeral after that ion name, and it's going to tell you what charge it is. So if we have Fe2+, we're going to call that iron 2. Fe3+ will be iron 3. Copper 1+ will be copper 1. Okay. Here, people have asked me, do you have to write the 1? I thought 1s were redundant in chemistry. Yes, because copper can also make copper 2. So if you just wrote copper, then I wouldn't know which one you're talking about. So if you want copper to be a 1+, you'll write copper 1. If you want it to be a 2+, you'll write copper 2. So let's look at this. Remember from last time, we have group 1A that are always going to form 1+, 2A will form 2+, 3A will form 3+. We're going to skip the 4A's for these charges. Then we have 3-, 2-, 1-, and we're going to skip these guys because they don't make ionic compounds. Okay, so now I want to look at the ones that we haven't paid attention to yet, and those are these transition metals. Okay, as you can see, a lot of the transition metals can make more than one charge. Like chromium can either be a 2+ or a 3+. You know, an iron can be a 2+ or a 3+. So a lot of these can make more than one charge. We also have these down here, which is why we haven't talked about them yet. These metals that are in group 4 and 5 can also make more than one charge. So if you see tin, lead, or bismuth, then you also need to include a Roman numeral. The ones that you need to memorize are these three, zinc, cadmium, and silver. And they form a 1+ or a 2+. It can help you memorize it here. If you look at this 1B, silver is in the 1B, so it makes a 1+. Zinc and cadmium are in the 2B, so they make a 2+. This doesn't always work because if you look, copper is also in the 1B, but it can form multiple charges, just like gold and mercury, so be careful. But of the ones that you need to memorize, silver's in the 1B, so it makes a 1+. Zinc and cadmium are in the 2B, so they make a 2+. Just to help you out. The ones with variable charges, I'm not going to have you memorize them in this class. If you go into higher levels of chemistry, though, you will need to start to memorize these. Okay, so thus far we've talked about if we have a metal with a variable charge, we're going to need to include Roman numerals. So our rules here are to write the cation name and then write the cation charge in the Roman numerals in parentheses. And then you're going to write the anion just the same. You're going to, if it's chlorine, it's going to be chloride. We're just going to change that N to end in IDE. But the new thing here is that if we have one that makes, a metal that makes multiple charges, we're going to need to include the Roman numeral for that cation in parentheses. So let's look at this one. So we have FeS, and we need to figure out, what we call this. So we notice, though, that iron is a transition metal. So that means we're going to have a Roman numeral. So we know that it's going to be iron something sulfide. Okay, because iron's a metal, so its name stays the same, but it's a transition metal, so we need to have some kind of Roman numeral. And then sulfur is our nonmetal, so we're going to change it to be sulfide. So right now we just need to figure out, okay, what is that Roman numeral? So we're going to use the charge of the sulfur to help us figure out the charge for the iron. Well, you'll notice that if we look at FeS, right, there's no subscripts. Since we, normally if we would have Fe something and S2 minus, right, that 2 would be, carried to the iron. But the 2 wasn't, right? There's nothing here. Which means the only time that happens is when these atoms directly cancel out. So if there's no subscripts at all, that means the iron and the sulfur have exactly equal and opposite charges. So if sulfur is a 2 minus, that means that iron must be a 2 plus for those charges to cancel. So that means that we are going to get iron 2 sulfide. Okay? So there we go, iron 2 sulfide. Let's try this one. So CrCl3. So we notice chromium is a transition metal. Okay, so when it's a transition metal, that means that we're going to have to include a Roman numeral. So we know that it's going to be chromium something chloride, but we don't know what the something is. So if we think about what it came from, though, we know it's going to be Cr something, and then Cl is in group 7A, so that means it's going to be a 1 minus. So if we think about circle and switch, that 1 from the chlorine went to the chromium, which is why there's nothing here. But the 3, you can think about, where did the 3 come from? Well, if we undo this, right, that means the 3 had to come from the chromium. This had to be chromium 3 plus, so that when we circled and switched, that 3 went to the chlorine. Okay, so you're just kind of doing the whole process backwards now to figure out what the charge on the chromium was. So this will be chromium 3 chloride, which is how we got that 3 by the chlorine. Okay, so again, we're going to name the cation just the same. So we're going to write chromium. Then we're going to see, chromium's a transition metal, so we need to write a Roman numeral. And then we're going to use that charge of chlorine to figure out that chromium was a 3 plus. So here's some examples, just in general that you may have seen somewhere, so that we have FeCl2 would be iron 2 chloride, Fe2O3, which you would be familiar with as rust, that's iron 3 oxide. So again, here we have iron 2, here we have iron 3. So so iron can change what charge it is depending on what compound it's making. So it's very important to include these charges here. And you have a bunch of other examples below. Go ahead and work on this on your Chapter 6 lecture worksheet, problem number 18. Once you're done, come back and we will keep going. Okay, so now we're going to write the formulas with compounds containing metals with multiple charges. I think what we just did before, writing the name, is actually the trickiest part because it's a little bit challenging to figure out what the charge of the metal is. I think writing the formula for our transition metals is actually really easy because it's telling you what the charge is. You don't even need to go and look at the periodic table or think, is this in group 1A or is this in group 2A? That Roman numeral is telling you the charge of the copper. It's helping you out. It's telling you, hey, copper here is a 1 plus, right? So that is actually saving you time because you don't need to go figure out the charge on your copper. So to write the formula, you're going to, find the cation symbol, so that will be copper, And we know that copper is a transition metal, so it can have more than one charge. But our Roman numeral is telling us what the charge is. So it's telling us that this is Cu plus. Okay, so then we're going to circle and switch to figure out the formula. So we have Cu1 plus, we have O2 minus. So when we circle and switch, we're going to get Cu2O. The 2 is going to go to the copper, and the 1, right, our imaginary 1, will go to the oxygen. So again, I think this is actually more straightforward than, even what we were doing last time, because this is telling you, right? It's telling you, hey, copper is a 1 plus. Let me help you. Let's try another one. If you're not familiar with Roman numerals, this is the Roman numeral 4. IV is 4. So this is tin 4 fluoride, and it wants you to write the formula. So again, we recognize, oh, hey, there's a transition metal, right? And that Roman numeral is telling us what the charge of tin is. So it's telling us that tin is 4 plus because it's tin 4 fluoride. And we know fluorine is a 1 minus. So when we circle and switch, the 4 is going to go to the fluorine. That 1 is going to go to the tin. So we're going to get tin 1, right, imaginary 1, F4. Okay, so go ahead and find lecture worksheet problem, problem number 19 to get some practice doing this. Okay, our other topic that we're going to cover today is how to write ionic compounds with polyatomic ions. And we talked about polyatomic ions last time. Polyatomic ions are a group of atoms that have an overall charge, right? Poly means many or more than one, so many atoms with a charge. So these are some examples of your polyatomic ions. I gave you a list last time that showed you all of the polyatomic ions that you need to know for this class. These are just some of them. But you'll notice that these endings are different, right? Typically, they end in ATE or ITE, and that will cue you in to the fact that this is a polyatomic and not an element, because you're seeing nitrate and nitrite, as opposed to if we had N3 minus, that is nitride. Obviously, it doesn't always help that it ends in IDE, right? Because like hydroxide ends in IDE and that's not an element. But a lot of times if you're trying to figure out, is it nitrogen or is it NO3 minus or is it NO3 or is it NO2 minus, you can look at the ending. Nitride is an element, nitrate and nitrite are polyatomics. Okay? You will see polyatomics everywhere. You see them all the time. Like, I'm sure you've heard of nitrates, right? Especially here in the Central Valley. If we're talking about farming, you'll hear a lot about nitrates in the soil, right? Well, now you know what nitrates are, right? NO3 minus. You might be hearing about ammonium, right? Or even ammonia, which is NH3. But this ammonium, right, is a polyatomic, and it is in a lot of fertilizers as well. Calcium sulfate, when you go get a plaster cast, that is SO4 2 minus. So these polyatomics are all over the place. And once you start to know them, right, now that you get to memorize some of them, you will start seeing them, on bottles. If you read the back of the, the bottle of things that you buy, you will start seeing these polyatomics all over the place. But again, they are a group of atoms that has an overall charge. So here were the polyatomics that you are responsible for memorizing. Hopefully last time you made flashcards and you've been starting to work on them. This lecture and all of the ones from here on out will go much easier if you have these polyatomics memorized. And like I said before, you will have a quiz on these polyatomics, so you really need to memorize them. The quiz will be like, if I write bicarbonate, you will write HCO3 minus, or if I write HCO3 minus, you'll write bicarbonate. So it's very similar to the element quizzes that we do. Okay, so how do we write the formulas, or how do we name compounds that have polyatomics in them? Well, it's actually pretty straightforward. We're just going to need to know our polyatomics. The name of our cation will be followed by the name of our anion, just like other times in ionic bonding. The names and formulas for all of those polyatomic ions should be learned. You should know them, okay? And we're just going to name the cation, name the anion. nothing special. So let's try this. So this is Na and then NO3. So we have sodium, right? We recognize sodium, and then we need to know what polyatomic is NO3. So you'll notice though, it's not charged, right? Because the charges get balanced out when we form that compound. So we need to figure out what was NO3 with some charge, or you could even be more advanced and you know Na is 1 plus, that means nitrate, to balance that out, that 1 plus out must be 1 minus. So if we find NO3 1 minus, that is nitrate. So this is sodium nitrate. So this one, KCN, so our K is our potassium, and so we need to know what is CN. We also know potassium is a 1 plus, which means that CN must be a 1 minus, so CN 1 minus is cyanide. Sorry, giving the game away. Here's another one. So this is ClO3. So we have lithium here. And so we need to know what is ClO3. So ClO3, and again, lithium's a 1 plus, and they are completely balancing out. So this must be a 1 minus. So ClO3 1 minus, that is chlorate. So this is lithium chlorate. And then here's one more, NH4I. So this one's a little bit different in that we don't have a metal at the beginning, right? You see this is all non-metals. The only time that will happen when we have all of these nonmetals is when our polyatomic is in the front. There is one polyatomic that goes in the front, one polyatomic cation that I'm having you memorize, and that's this one. It's NH4 plus. And then we have I minus. So NH4 plus, that is ammonium. And so this will be ammonium iodide. Okay, and just real quick, I want to go, if you'll go, we'll go look really quick back at this list of polyatomics, just so I can point it out. Go all the way back. There is only this one that's positively charged. Ammonium is the only one that will show up in the front of the compound, like that last example. All of the other ones will start with a metal, and they will end with the polyatomic. Okay, so I just wanted to point that out. We'll go back forward now. Okay, so here are some other compounds that have polyatomics in them. And they have a lot of medical uses, right? So like aluminum phosphate is going to be used as an antacid. We have aluminum sulfate, which is in a lot of deodorants. That's an antiperspirant, right? And so we use a lot of these compounds, right, to have medical uses or just uses in our daily life. So it's really important to be able to recognize and name these types of compounds because, you know, a lot of times they'll put just the name on the bottle. And now if you know your polyatomics, that name will mean something to you and you can actually figure out what's in it. Okay, go ahead and get some practice on this and work on lecture worksheet problem number 20. Okay, so now we're going to learn how to write formulas for ionic compounds with polyatomic ions. So our example here is we're going to write the formula for magnesium nitrate. So we're going to do like what we've done for all of the other ones. We're going to write the cation and the polyatomic ion now, instead of just the cation and the anion. So we have magnesium is magnesium 2 plus, and we have memorized nitrate because we are good chemistry students, and I told you to start memorizing things. So we know that nitrate is NO3 minus. So when we circle and switch, the 2 is going to go to the nitrate, and that imaginary 1 will go to the magnesium. So when we do that, though, the magnesium, right, we'll get this 1, so it's Mg imaginary 1, but that 2 needs to go to the entire nitrate. So it needs to go to all of this. So we don't just write it as Mg, because I see this a lot. People will do this, but now it looks like you have 32 oxygens, which is not what we want. People will also do this. Also not correct. We need that 2 to go to all of the nitrate. And so the way that it goes to all of the nitrate is we will put nitrate in parentheses. So what I like to think about is if I draw a line under nitrate, right, NO3, anything that touches the bottom will go in a parenthesis. So that's how we end up with NO3 here. And then the 2 will go on the outside of that parentheses. So now it will tell you that there are 2 nitrates because that 2 can distribute in just like math class. So the 2 will go on the outside of the parentheses, and then we don't write that 1 minus. Let's try another one. So if we were to do aluminum carbonate, so we have aluminum is a 3+, carbonate is CO3 2-, and I'll write it over here because it's a little bit tricky to see under that. So the 2 will go to the aluminum, so we get Al2, and that 3 is going to go to the carbonate, but it needs to go to all of the carbonate. So again, anything that can touch the bottom is going to go in parentheses. So we'll make a parentheses, CO3, and then end parentheses, and that 3 from the aluminum will go on the outside. Let's try another one. Sodium sulfate. So we have Na+, SO4, 2-. So the imaginary 1 will go to the sulfate, and the 2 will go to the sodium. So we get Na2, and then we're not going to include parentheses here because that 1, right, we're not going to write that 1 on the outside of the sulfate because we don't write 1s. So we're not going to put the sulfate in parentheses here because we don't need them. There's nothing that's going to go on the outside of the parentheses. So we will just write SO4. Go ahead and try lecture worksheet problem number 21. Okay, before we move on completely, I want to do 2 more examples just so we get a little bit of practice. Okay, so let's try calcium carbonate. So if we had calcium carbonate, calcium is a 2+, and carbonate is a 2-. So our charges are exactly equal and opposite. So instead of doing our circle and switch, right, when things are exactly equal and opposite, they just cancel out. So we're just going to write them together, CaCO3. No circle and switching necessary. Here's another one. Let's say we needed to do ammonium sulfide. And ammonium was that one polyatomic that I told you can appear in the front. And you'll recognize it, you'll recognize it because it's not an element and you're going to look on the periodic table and you can't find it. Would be the easiest way, but also if you have it memorized, that would be super helpful. So we know ammonium is NH4+, and sulfide is S2-. So that 2 is going to go to the ammonium, but it needs to go to the entire ammonium because it's a polyatomic. So again, we're going to put everything that touches the bottom in parentheses. So we'll go NH4 in parentheses, and that 2 is going to go on the outside, and then our imaginary 1 will go to the sulfur, so we don't need anything on the outside of the sulfur. Okay, so those are 2 other examples that I think you will find really, really useful. So thus far, in the past 2 lectures, we have talked about ionic bonds. In the next lecture, we will talk about covalent bonds, but ionic bonds tend to be a little bit trickier, so I wanted to spend 2 lectures talking about them. So ionic bonds are always going to be a metal and some, at least 1 or more nonmetals. So when we have just a metal and a nonmetal, so we had a metal or ammonium, if it forms only 1 positive ion, we're just going to use the name of the element. If it forms more than 1 positive ion, then we need to have a Roman numeral. And so again, this will be for the transition metals. Okay. So you're either going to write just the name or write the name plus a Roman numeral for the transition metals. For the nonmetals, it will either be 1 element, right, a monatomic ion, which means that you're going to change the name of the element to end in IDE. So like fluorine becomes fluoride or sulfur becomes sulfide. If it's a polyatomic, then you're just going to use the name of the polyatomic when you're naming it. So you need to make sure that you have those memorized.